Welcome to Click Academic. This is lesson number 6 on the series of set theory and logic, and we will be discussing on well-formed formula. We are still under logic. We finished with connectives. Now we are going to talk about what we call well-formed formula. We said a well-formed formula is being denoted by this, or let's say well-formed formula. This is how we denote it, which is the F. That's how we denote it, well-formed formula. We say that all proposition statements are well-formed formula. That is, if they have a word, a truth value statement, that is their word, well-formed formula. Now, let's assume if you have P as is a statement, if your P is a well-formed formula, therefore, negation of P is a what? Is a well-formed formula. Meaning, if this is a well-formed formula, therefore, when you take the negation of it, it will be well-formed formula. Why? Because let's say P is true, then negate true, it will be false. And remember, we see that a proposition is a statement that is either true or false, but not both. That is what we mean by well-formed formula. It still satisfies the word, the meaning or definition of proposition. It's a statement itself. Then we now say, okay, if you have, let's say you have P and Q as a well-formed formulas. This implies that P if and only P implies Q, then P if and only if Q, P and Q, then P O Q, and P exclusive O Q are all well-formed formulas. Why? Because if you see this, all this is our connectives, the one that we learned in the previous lessons. This is if and only if, this is by implicative, this is by implicative, this is conjunction, this is disjunction, and this is exclusive O. And in the case of negation, we talk about negation is a unitary connectives. So negation is not simple. When you have, let's say you have P, then when P is true, then the negation of this P, which is symbol like this, it will be what? What's the opposite of true? It's false. That's what we mean by negation. So, therefore, let's take something. Let's say, okay, now when you said we have something like this, negation of P, another, let's say we have negation of P in bracket. Let's say we have another negation of P implies Q. Now, among these, which one is well-formed formula? Which one does it satisfy the logical operations? You understand? Now, when you say negation of negation, it will give you P. But this bracket doesn't make sense. Why? Because we don't have a connectives. We don't have any sentential connectives here. So therefore, this bracket cannot exist. But this one, it exists. Why? Because we have a sentential connectives inside, which is implies. Right? So therefore, this is not a well-formed formula. Why? Because there's no sentential connectives and we are putting a bracket onto it. But we can have negation of P. It's a well-formed formula, but we cannot have the bracket of it. In a logic, bracket means a lot. So you have to be careful what you are taking a well-formed formula. So thank you very much.